Hello everyone, welcome to today's webinar. Today we're going to be talking about integrating R with ArcGIS. This is part one of a two-part webinar series. The second webinar will be held on Tuesday, March 29th, so basically next week at this same time. My name is Cameron Plouffe. I'm a higher education developer / analyst at Esri Canada. If you do wish to contact me, you can use the email listed on this slide, or I'll also provide contact information at the end of the slideshow. So just a few notes on getting started with WebEx. When you join the webinar, you are prompted to join the audio broadcast. So if you want to listen in, you have two separate options. You can either use your phone and dial in using the toll-free number provided on the screen, or you can listen in using your computer speakers or headphones. Today, we're going to be doing a lot of live demos in an RStudio IDE. So for the best view of today's presentation, you may want to go full screen, especially for some of the smaller text. You can click the full screen button that's indicated in the slide and click that in your WebEx toolbar, and you'll be able to make the presentation in full screen mode. At any point during the session, you can also click the big blue arrow that will be in the full screen mode, and you'll be able to return back to the default view. So if you do have any questions about the content of the presentation today, you can ask these questions throughout the session. So what you want to do is you'll select the host, who is Ian Greensmith. He is one of my higher education group colleagues, and send the questions to him. So select him, type your question in the box in the chat window, and then click send. Please feel free to type a question at any time, or if you'd rather do so, you can email me offline and I can get back to you. So I will have my contact information again on the closing slides. Last thing is that this session is being recorded. So if you do miss anything or something goes by too fast, we'll be sending the recording and the presentation out after the webinar to everybody who's registered. All right, so let's get started. I'm just going to give you a brief outline of what we're going to cover today. So here's the webinar schedule. We're going to have an introduction to R. So a lot of people may be already familiar with R, but we are gearing this towards a GIS demographic. So we want to make sure that everybody's on the same page. We'll do some basics, talk about R, what it is, development environments that you can use to develop R scripts, R basics. Then we'll go into third-party packages. We'll talk about a number of useful third-party packages that you can use to extend what R can do. We'll talk about dplyr specifically and data manipulation with the dplyr package. And then after that, we're going to go into the R-ArcGIS bridge. And we'll talk about installing the R-ArcGIS bridge, also using the ArcGIS binding package within R, reading and writing data from geodatabases, and lastly, we'll do visualization of those data using ArcGIS Pro. So let's get started. So R. Many of you, I'm sure, have already used R if you are already registered for this session, but just a brief outline. What is R? So R is an open programming language used primarily for statistical computing and data analysis. It can also be used for different types of spatial analysis as well. So if you do want to do spatial analysis, it's definitely able to do that. It is an implementation of the S programming language that was developed at Bell Laboratories by John Chambers in the mid-70s. And R was actually, I believe, developed in the mid-90s. And one of the best things, to me probably the most compelling thing, reason why you want to learn R is the very active user community that are constantly contributing new packages. So packages are basically just bundles of different functions and data that are dedicated to a certain task or a certain subject, and anybody can publish a package. And as of right now, there are over 8,000 packages available on the Comprehensive R Archive Network, or CRAN. And CRAN's basically just a repository where all our packages are stored, and they actually do validation to make sure that there's certain standards are met for our packages, which is very useful. And honestly, every time I log on to CRAN, it seems as though there are 1,000 more packages than the last time I looked at the total number. So this is increasing every day. And with R growing as a language, it continues to increase at a more rapid rate. So I've briefly touched on this, but why would you use R? So R is the de facto standard language for statisticians. So if you're reading any sort of papers on new statistical methods, most state-of-the-art statistical methods have already been implemented in packages available on CRAN. So instead of having to implement them yourselves, you can go in, you can search this given method on CRAN, find what's going on, and also download that. And instead of having to implement it yourself, you can use somebody else's implementation, which is very useful in a research context. R is one of the fastest growing programming languages over the past approximately 5 years. And I think with the rise of sort of data scientists and working with larger data sets, R is one of the key tools of a data scientist's tool belt. So I do think it's very useful for any sort of data manipulation, data munging, data wrangling, all that type of stuff. R is very, very powerful for. Lastly, R is also a powerful language for creating high quality plots and graphics. So these are publication quality plots. You can use base R to create your plots, or you can use extra third-party packages such as ggplot2 or ggvis. And these are packages developed by a man named Hadley Wickham, who I'll be touching on a few times in this presentation. He is one of the preeminent R developers. So now that you know the what and why, where can you develop R? So what can you use to develop your R scripts and your different R, say you're making applications? You can use RStudio. So RStudio to me is far and away the most powerful R integrated development environment. It's an open source and enterprise ready professional software for R. And RStudio really allows you to manage all your work in one place. It also has a scripting pane where you can store your R source files, a console, and lastly, one of the most important things about R is this developed and maintained by a team of reputable software engineers, including Hadley Wickham. So as I mentioned before, Hadley Wickham's probably, if not the most important, one of the most important figures in the R community. He develops many of the most used packages, some of which we'll touch on today. And he actively develops RStudio. And because of this, a lot of these packages are integrated right into RStudio. So it's really good. Lastly, you can use RStudio projects to keep your work organized. And this is good for me. When I used to work in R before RStudio, sometimes I would have my data all over the place and my R scripts all over the place. And just having these projects allows you to keep yourself organized and also keep your workspace organized. So you'll have one workspace associated with a given project. So if you don't want to use RStudio, perhaps you're a Visual Studio user, you can use the recently announced R tools for Visual Studio. So these are actually very recent announced, and you can click the link in the presentation. I'll provide this after. And this has basically a press release about this new plugin for Visual Studio. So it's going to basically allow you to do more integrated R development in Visual Studio, including IntelliSense, code completion. You'll also have a plot and a console and a scripting pane. It's very useful. So this hasn't yet been released. It's soon going to be released, and you can sign up for an early access version by emailing the email address that's listed at that link. So before we go any further, I'm actually just going to show you, today we're going to be working in RStudio. So I'm going to give you a very brief outline of the components of RStudio. So let me just bring that up. And there you go. So hopefully you can read some of this text, but this is RStudio. And this is a configuration of the panes that I've chose. This is not the default configuration, but I like to have my script pane large and on the left side. So my scripting pane is where I'll open all my R source files, whereas on the right, in the bottom right, you've actually got your interactive R console. So I can type right into here, say I want to just set a variable x equal to 1. Now we've got that. We can also print out the variable by just typing in its name. And we also see that in this other pane, this top right pane, we have the environment. So the environment is just basically tells you all the objects that are available within your R workspace. So this will build up as a project increases in size. You can go to your history pane, which will tell you all the commands you've sent to the console, files, which right now I've navigated to the root location of my R project. So I like to keep my data, my R source files, and my documents all sorted in different folders within that. If you have any plots, you'll be able to see them in the plotting tab, packages you have loaded, help, and if you're managing something with Git, you can do version control within RStudio. So as you see, it's a very useful IDE. So let's hop back into the presentation. So getting started with R. So for those of you who are experienced R developers, this will seem relatively basic, but as I said before, we'd like to keep everybody on the same page. So we're going to quickly go through some R basics, and I'm basically going to be going through an applied sort of tutorial within RStudio just to show people exactly how you work with R data sets. So, R data types. R offers many of the standard data types you may be used to using in other languages, say more general purpose programming languages like Python, or even web programming languages like JavaScript. So you have numeric, integer, logical, which is essentially just a Boolean, characters, which are strings, and lists. So these are all probably relatively familiar with you if you've been programming for any amount of time. R also has several unique data types. So some of these are really what makes R a powerful environment for data analysis. So you have vectors, data frames, matrices or matrix, and factors. These are just some of the unique data types available to R. So let's hop into RStudio now, and let's go through a little bit of basic and some explanation of R code. So the first thing I'm going to do is I'm going to use R as a functional programming language. So pretty much everything you do involves calling a function. So we're going to call the source function here, and we're going to source a file located in our R directory. So we have R folder right here, and we're going to source the R helper functions. And what that's going to do is it's just going to load everything from the R helper functions folder into our workspace. So we can see we loaded up a function called load packages. We can click this and we can inspect the source code. And don't worry about the code here so much as I've written this function. What it does is it takes a list of packages, and what it does is it installs packages that haven't already been installed on your computer, and then it loads them all up. And the only reason I wrote this function is because I guess I'm a little lazy and I don't always want to check which functions I have installed and which ones I need to install. So this will do that for you. And you would just pass a character vector to this function. So I'll do that right now. So this is how you create a vector in R. You can use the C function or combine. And this is a character vector in that it has only character or strings in the vector. So one thing, a vector is essentially just a list of values that are all of the same type. And they need to be of the same type. So if you pass characters, it will always be a character vector, or a numeric vector, or an integer vector. That's basically what a vector is. So let's create the packages vector. These are the packages I want to load up. SP, which is for handling spatial data in R, and dplyr for data manipulation. I'll create that variable, and now we use load packages and pass in the variable to this function. So remember, we loaded this function from the helper functions file. So the fact that we didn't get any output is usually a good sign in R. That means there wasn't an error, so the packages were loaded up successfully. Great. So let's go a little bit more in depth, still some simple stuff. Let's create a numeric vector here. So some of the first numbers of the Fibonacci sequence. So fibnums equals, and then we'll create this. If we say class of fibnums, that will tell us the data class of that vector. And as we can see down in the console, it is numeric. So that's great. So now let's evaluate some basic conditions that we can look at basic vector subsetting and indexing. So fibnums is greater than 5. That is a condition. If we evaluate that, we return a logical vector. And a logical vector is essentially just returning Booleans corresponding to each index in the vector. So false, 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 these are all corresponding to 0 through 5, as 0 through 5 are not greater than 5, whereas true is corresponding to all the numbers greater than 5. We can pass this logical vector within square brackets to fibnums to index. So if we do that, it's only going to return the values that are true. So we've only returned the values 8, 13, 21, and 34, as those are all the values that are greater than 5. We can also store this condition in a variable. And sorry, I should have mentioned, I'm pressing Control-Enter in RStudio to send the code from the scripting pane to the console. So we condition equals fib less than 5, and then we can evaluate that condition in square brackets again to index fib numbers. And now these are just a slightly more complex operations using different operators. So we have the not equal to here. So we're saying, let's see fibnums, evaluate fibnums where fibnums is not equal to 5 and, using the ampersand, not equal to 0. We see we get all the numbers not equal to 5 or 0. We can also use the pipe character right here. And that means or. So we're saying fibnums where fibnums equals 0 or 1 or 2 or 5. So that's only going to return 0, 1, 2, and 5. lastly, we can use the in operator to evaluate this. So we fibnums in, and we can pass it a vector. So give me all the values that are in this vector. And then the very last example, not in. So if we wrap everything with an exclamation mark, this will give us everything that's not in that. Sorry, I sent that to the console. Let me try this one more time. And there we go. Every number that's not in 0, 1, 2, and 5. So very basic stuff, but feel free to play around with that. Now let's do a quick review of data frames. So data frames are the data format that R uses to store tabular or rectangular data. And it's really one of the most powerful data types in R, in my opinion. I use them all the time for storing tabular data, and you can do quick manipulations on data frames. So one thing I should mention is that all source data used in this webinar were obtained from the Toronto Open Data Catalog and are licensed under the Open Government License of Toronto. So this will also be linked to in the README file. I'll be uploading all of this code to a GitHub repo, and I'll provide the link at the end of this presentation. We can use base R in the read.csv function to read in a CSV file and create a data frame from that. So the read.csv function is as follows. We can assign this to a variable, say read.csv, pass in the location of the CSV. So this is a relative path, so it's in our data folder. If we go here, data, toronto-crime.csv. And then we also pass another argument. And I'm not going to go into details about strings as factors equals false, but essentially what we can do is we can specify that we're not looking to import any strings as factors. We want them to be imported as a character vector. All right? So if you want to read up on this, you can use the help. So if you type read.csv, that will open up the help file, and you can read sort of all the different arguments for that function. So feel free to do that if you want to find out more about strings as factors. So let's load that in. Let's store that as crime_df. We can check the class of that, and we can see it's data.frame. So now we can also inspect the data frame by printing it to the console. Let's do that quickly right here. You can see this is a little bit unwieldy. We can't look at exactly, I can't parse this at least. A computer can parse this. So let's use the view function to make this a little bit more interpretable. And what we can see is that it brings up a spreadsheet-like window, and we can actually just view the data. And these are crime data associated with different neighborhoods across Toronto. So we see we have population, area, and a number of different crime count data for different types of crimes that were committed in Toronto by neighborhood. We can also use the str or structure function to get an idea of the structure of that data frame, or any data type really. So you can see the $sign is used to access columns in a data frame in R. So we can see we have the area SCD column, the neighborhood column, and we also see the type. So one thing you should know about data frames is they're essentially just collections of a number of different vectors. So each column is basically a vector. So that means it has to have a common type for every single value in that column. So we can see area SCD is an integer character. Most of these are integers because we're working with count data. There are a few numerics at the bottom for something like equity score, which is derived from some of these other values. Okay. So I'm going to go through very quickly through some subsetting and indexing examples. And you can see this is, for data frames, this is very similar to working with vectors, except for now we have two-dimensional data. Therefore, we have to specify an X and a Y. So for subsetting crime DF, we can use the square brackets to subset, but we use a comma. On the left side of the comma is anything we're using to subset rows, whereas on the right side of the comma is what we use to subset columns. And in this case, we don't want to do anything with the columns. So let's subset where crime, we're using this $sign access to access a given column. So we're saying crime, where crime neighborhood equals Yonge and St. Clair. We send that through and we get one record, one row back where the neighborhood is equal to Yonge and St. Clair. We can also do similar operations to as what we were doing before, where arsons are greater than or equal to 5. And this is just an output of that, of all the records where that is satisfied. We can also do use the AND to specify two different conditions. So assault's greater than 300 and assault's less than 350. So essentially assault's between 300 and 350. We can pass a numeric vector to specify the actual row numbers. So here we want rows 1, 2, and 3, and that's just returning the first 3 rows. You can use the nCall function to find out how many columns are in the data frame. Now let's talk about subsetting by column. So instead of on the left side of the comma, we're specifying on the right side of the comma. So if you want columns 1, the first through the 3rd column, send that in, and those are the first 3 columns of the data set. You can also specify a character vector of the names of the columns you want to see, so thefts and arsons. And lastly, we can do both of these at the same time. So say we want to subset by rows and columns. Let's send this over to the console, and we'll see these are rows or records where vehicle thefts are greater than 100, and then we only want to view the area SCD column and the neighborhood. Okay, so I've included a few challenges. I've actually included the solutions in here as well, which maybe you don't want to look at. So if you want to get your hands dirty and start working with these types of things in R, by all means, play around with these challenges. I'll post a version onto GitHub without the solutions as well. So if you want to try and solve these challenges, I'm not actually going to go through these today, but feel free to go through them. Okay, so that's basic R stuff, and let's go back into the presentation now. Okay, so while that's all great, one of the best things about R is using some of the many third-party packages, and these packages extend the capability of base R. So some examples of packages that I've used in my experience: the Hadley stack, which is referring to Hadley Wickham again. These are all packages that he's developed. So ggplot2 is sort of the best, in my opinion, the best plotting library and graphics library or package for R. It is based off the Grammar of Graphics book by Leland Wilkinson. So it's a great library, and it makes it very easy to me to plot different types of tabular data. You can use dplyr for data manipulation, which we'll do in a second, stringer for string manipulation, tidyr to create tidy data sets if you want to look that up. There are many articles about what a tidy data set is. DevTools for package development, which is really expedites the process of package development, makes it much easier to do. If you're looking into statistical modeling, there's CAR, LME4, Caret, MGCV. So these are all for, I think, complement to applied regression, mixed effects models, machine learning, generalized additive models. All those are available in R. If you're working with spatial data, you can use the R-ArcGIS binding package, which is what we'll touch on later in the tutorial. The SP package, which is basically the standard data model for spatial data in R. And ArcGIS binding can interface directly can save objects to SP objects. So it's very easy to work with both formats, and map tools as well. Lastly, time series, you can work with Zoo, XDS, and Spacetime. There are really so many different packages. And if you want to learn about a specific task or a specific domain, you can click this link here, the CRAN task views, and what that will provide for you is a list that is sorted by a given topic. So you have Bayesian inference, machine learning, biostatistics. All these things will be available to you by going to the CRAN tasks view. So we'll go through, after this we're going to actually be digging right into the ArcGIS binding package. But first I wanted to talk about dplyr for data manipulation. This is a package I've used very much in my own research. So it's developed by Hadley Wickham to give users a fast, consistent tool for working with tabular data in R. So it improves on many of the base R methods for data frame manipulation. And what I mean by improve is that these methods are much faster, and to me the syntax is much more intuitive and consistent. There's a function for each basic verb of data manipulation. So filter, arrange, select, summarize. These are all verbs that you might be familiar with if you've used SQL. So these are very similar to SQL, how you would interpret a filter in SQL or a select in SQL. And it also, to me, this is probably one of the biggest factors of dplyr, the biggest important features that it brought to R, is the forward pipe operator. And this helps you produce more intuitive workflows in R. And I will demonstrate this a little later on. I think this really revolutionized the way at least I write R code. So I recommend it to everyone. So let's go through a few dplyr examples. So the first function we're going to touch on is the filter function. Filter is very simple. It just allows you to subset rows from a data frame similar to base R. So exactly what we were just doing. We were doing crime df crime equals, or look at crime DF where the neighborhoods equal to Yonge and St. Clair. So that's fine, but we can also use the filter function to do the exact same thing. But I find the filter function syntax to be a lot easier to understand. So you're saying filter, pass in the data frame you want to filter, and then you can say neighborhood equals Yonge and St. Clair. And this is also, if you're working with larger data sets, this is much faster, as all dplyr is implemented in C++ as opposed to R. So it runs much faster behind the scenes when you're working with large data sets. So I'm going to send this through. You can see same result as above. You can also pass multiple conditions as arguments to filter. So say you want to evaluate where arsons are greater than 3 and thefts are greater than 10. We can do this by clicking filter and passing these both. This is going to evaluate both of these conditions. So it's going to think of it as using an ampersand between the two. If you want to use the standard Boolean operators like the pipe character to use or, that's totally fine as well. Filter crime DF where arsons are greater than 3 or thefts are greater than 10. Okay, so these are a few more examples if you just want to see how you use filter. But it's pretty straightforward in my opinion. So you can see right there, actually, I should mention that returned 0 rows. And that's because those conditions where both of them were true was never satisfied for any row in our data set. So that's actually the correct answer, a data frame of 0 rows. Okay, let's talk about arrange. And arrange is exactly what you would think it does. It sorts rows in a data frame based on a set of column names provided to the function. So if we go arrange crime DF, and let's arrange by the arsons column. Send that in there. Well, you look at this and you're like, I don't know. Did that arrange by the arsons column? I'm not entirely sure. So let's wrap that arrange in the view function. We can use the view function around the result produced from arrange to open that up in that spreadsheet-like format. And what we can see is that as you scroll down, arsons increases. So it's sorted from 0 in ascending order up to 6 right at the bottom here. If you wanted to do the opposite of that, you wanted to do descending order, you can wrap the column name in the DESC or descending function. And I'll show you that really quick. Sorry. And you can see now we're going from 6 down to 0. You can also sort by multiple different columns. So this is going to do within group sorting, and this is really useful. So I'm going to show you sort by arsons and then sorts by assaults. So if we do that, we can see we're still sorting by arsons first, but within each arsons group, we're sorting ascending assaults. So it's going 16 and then it's ascending until it reaches the last 0, which is 278 assaults, and then it's starting again in the next group. So for everything with one arson, it starts again at 28 and will go up, as you see. Okay, so that's basically arrange, pretty simple stuff. Now we're going to do select, another very simple thing. It allows you to select specified columns or variables from a data frame. So select area SCD and equity score. Let's do that. We've only selected those 2 columns from the crime DF data set or data frame. We can also use the negative sign in front of the columns to indicate that we want to remove those columns from the data set. So if we do view, select crime DF, and then minus arsons and minus assaults, we'll open that up and we can see now we no longer have the arsons and assaults column in our data set. Okay, so now we're getting into some of the more interesting functions. And as soon as we're done with these ones, we're going to go right into the ArcGIS binding stuff, and we'll show you how you can use this with your ArcGIS data sets to do some more advanced manipulation of your data. So summarize is a function that allows you to summarize values from a data frame. So I'm going to send in summarize, and then we're going to say a mean fire is going to be equal to the mean, which is a function in R, and the mean of the fire vehicle incidents column, okay? Total assaults is going to equal to the sum of all the assaults. We do this. One second, I need to escape this, and let me try this one more time. There we go. So the mean fire vehicle incidents or number of fire vehicle incidents is 88.2, whereas the total number of assaults is 21,087. We can also use the summarize each function to pass a character vector of the functions we want to summarize a given column by. So we've got the mean, the sum, and the standard deviation. And this is pretty simple, but if you use this in conjunction with the group by function, which allows you to group data sets, it's very, very useful. And I'll show you that a little later on. Okay, this to me is the most important thing, and this is really why I wanted to to show dplyr is that you can use the forward pipe operator. So it allows you to pipe or send a value forward into an expression or function call. And in abstract terms, which may not necessarily make this easier to understand, I'll show you an application right after. If you were to think of a function call as f at x, the same function call can be made using the forward pipe operator using the syntax x pipe f. If additional arguments need to be passed to the function, for example, f at x, y, an equivalent function call using the forward pipe operator would be x pipe f at y. So that might be confusing, so let's actually just show you what I mean. So here we're wrapping the select in view. So we're wrapping the select function with the view function. And that's what we've been doing to view these, and we said select just the arsins column. We could do the same thing by storing that in a variable. Say we store the result from the select in crime arsins, and then view crime arsins. Same exact thing, we're only looking at one column. But if we wanted to use the dplyr forward pipe operator, we could write select crime df, the arsins column, and then pipe that value to the view function. So if we send this through to our console, you see all three of these return the exact same result. So you might be saying, well, that looks more verbose. Why would I want to code that way? Well, when you get into more complicated workflows, it really does help to simplify the workflow and make it much more intuitive to understand and read. So let's go on, and I'll show you a workflow, for example. So let's take our crime df data frame. Let's filter it where the equity score is greater than 80. Select the neighborhood thefts and vehicle thefts column, and then arrange that by the thefts and vehicle thefts columns. So you see that workflow is relatively intuitive if you read through the code. You don't need to necessarily be an R developer to understand that. But what it did is it was pretty powerful. So now if we want to do that, replicate that same workflow with base R syntax, not using the pipe operator, or sorry, the forward pipe, we can see this is the same syntax. So this is a little bit more confusing for me, at least, to understand. Arrange, select, filter, then a bunch of different parameters that you're passing to all these functions. I myself can't interpret that very easily, whereas if I read this, it's much easier for me to sort through. Okay, and here's the same sort of example using other means, so storing the temporary values or the intermediate values in variables. This is the last thing. We're just saying you can group by function. Group by allows you to group a data frame given a variable. This grouping can then be used to apply further functions on the data frame. So let's do group by crime df arsins, and then we can say summarize the arson groups that we just created by mean fire. And that means the mean fire vehicle incidents for each group. So let me just show you what this is, and that'll probably be a little bit more intuitive. So what you can see in the output is that our data has been grouped by the number. So all the neighborhoods with 0 arsons, we calculated the mean for all those neighborhoods. All neighborhoods with 1 arson, we calculated the mean. And you can see, I'm not going to say there's statistical significance here, but you can see generally as arson seems to increase, so does the mean amount of fire vehicle incidents. Okay, so that's enough dplyr. Let's go right into the R-ArcGIS binding. So R-ArcGIS Bridge, what is it? It allows ArcGIS developers to create custom tools that integrate R with ArcGIS, but it also allows R users to access their organization's GIS data managed in traditional GIS ways. So think in an SDE or a standard geodatabase. Now you're able to interface directly to that, and I can't tell you how helpful this is for me. In the past, I would have loved to have the ability to do this, but it was never really an easy thing to do from within R. Now you can directly interface right to your geodatabases. So say you want to store your data in ArcGIS, access it quickly in R, return your R objects back to ArcGIS native data types, and very easily done with the R-ArcGIS Bridge. Also, you can convert your spatial data to SP objects to work with it in R and perform analysis. So you can go to this link to find out more. We're going to install it right now. So installing the R-ArcGIS Bridge, you navigate to this GitHub repo that I've linked to here and download the Python toolbox. Before installing it, ensure that you have the correct version of R and ArcGIS installed. So this would be R 3.1 or later, and either ArcGIS Pro 1.1 or ArcGIS for Desktop 10.3.1. So if you're using ArcGIS Pro, that will be for 64-bit R. If you're using ArcGIS Desktop, it will generally use 32-bit R, but you can also use 64-bit R with ArcGIS for server and background geoprocessing. In the future, we'll be able to use the Conda package management system to manage our R environments. So I'm going to do this right now. I'm going to install the R-Bridge install. So if we click here, we can visit the GitHub repo, and you can see there are instructions to install the R-ArcGIS Bridge. I'm actually just going to show you, so I won't go through those. So you can either click this button to download the R-ArcGIS Bridge, or you can git clone it if you're familiar with GitHub. So that's what I'm going to do right now. Copy this link to my clipboard, open my console, and let's go git clone to my C drive. We're cloning into it, and now if I navigate to my C drive, we can see we've downloaded the R-Bridge install folder. So I'm going to open ArcGIS Pro now, and we're going to install the R-ArcGIS Bridge. So give it a second, it's initializing on the other screen, so you won't be able to see it for a second. There we go. So I'm going to open the project. This project is also available through the R-ArcGIS webinar GitHub repo that I'll be providing after the webinar is finished. So you can see we actually have a feature class in here that has basically the same data we've been working with throughout the set, except for now we have polygon geometries associated with each neighborhood. So we can scroll through and see different attribute data. So let's go here and let's add this toolbox. Go to toolboxes in our project pane, add toolbox, and let's navigate to our R-ArcGIS Bridge. So R-Bridge install, and now we have the R integration Python toolbox. Select that, add it to our workspace. And now we can open this toolbox and we can choose one of these tools. And I'm going to use the install R bindings tool. So basically you can double click this tool, click, I'm going to overwrite existing installation because I may already have it installed, and then click run. And the tool takes a little bit of time to initialize, but once it will check essentially where you're storing your current R libraries, and then it will install both the 64-bit and the 32-bit package for ArcGIS binding, depending on which versions of R and which versions of ArcGIS you have installed. So give it a second. It should be complete relatively soon. But I just want to show you how easy this is to install. It's really just a matter of running a tool. It's running the script right now. And there you go. So it's completed with warnings, but the warning is just telling us that it installed to the library, and this is where I keep my R libraries. And you can find this by looking at your R-libs path if you want to change this to a different directory. Okay, so that's great. That was easy. That was pretty straightforward. So let's go back to the presentation. There we go. Okay, so what we've installed is the ArcGIS binding package. This package allows our users to access data stored using native ArcGIS data types. So for example, ArcGIS database feature classes, and you can use the ArcOpen, ArcSelect, and ArcWrite functions, which we'll go through in 1 second. We can convert ArcGIS data to an SP object or a spatial object within R and perform some analysis, then write that back to a geodatabase using the arc.data2sp and arc.sp2data functions. Lastly, you can convert between Wicket and Proj4 projection strings using arc.from P4 to Wicket and the other way around, and also interact with geometries using arc.shapeinfo and arc.shape2sp. So this is only if you want to work exclusively with geometries and not with any of the attribute data. So let's go right back into our RStudio, and now we're going to work with some spatial data. So what we want to do first is use the library function to load the ArcGIS binding package. And what it tells you is that you need to call arc.checkProduct to define a desktop license. And this is just to ensure that you have ArcGIS Desktop installed on the machine you're trying to run the ArcGIS binding package on. So if you run arc.checkProduct, we're in luck. We've got ArcGIS Pro installed and the license is advanced. So now we can go through and use the ArcGIS binding package. So if you want to find out more about some of these functions, you can use the help file. So help arc.open. And what arc.open does is it opens an ArcGIS dataset, table, or layer, and then returns a new Arc dataset class. So let's do that now. Let's connect to our geodatabase. Input FC, let's specify the location of our geodatabase and our feature class specifically. So data/arcgis, R-ArcGIS data.gdb/Toronto_crime. And now let's pass that to the arc.open function. And now we will have connected to our Toronto crime feature class. So we can inspect this if we want to, see the class of Toronto crime. It's an arc feature implementation and ArcGIS binding. And if we want to actually view a few details about this data set, we can print it to the screen. So it says there's a feature class, this is where it's stored, these are the fields, the extent, the type of polygon, and the wicket string for the projection. So it's all there. Now let's say we want to actually work with the data in this data set. So crime fields is equal, so what we can do is we can specify fields that we want to select from our ArcGIS data set. So say crime fields is equal to neighborhood and hazardous incidents. These are the two fields we want to query essentially and return in a data frame object in R. Crime fields equals combine these two, and now we can use the arc.select function. And the arc.select function allows you to filter data and provides a means for just loading a spatial object to an ArcGIS data frame. So we've done this, and now we can go view of Toronto data frame or Toronto hazard DF, and we see we've got the two columns that we selected in a data frame format. The one difference between this and a standard data frame is that an ArcGIS data frame retains the spatial attribute data and all of the geometries that a normal data frame would not have. If we wanted to work with this in a traditional R spatial sense, with an SP object, we can use Toronto hazard SP and use the arc.data2sp function. So if we send this through and then we pass in the data frame, the ArcGIS data frame we just created, this will create a SP object. And now we can use the spplot method to plot that data just to show that there are actual geometries associated with each one of these. And there you go. In our plotting pane, we've got neighborhood and hazardous incidents, just a quick plot to show you that these spatial data are actually available within the R environment now. If you want to access only the data frame from that, you can use the @data slot, which if you want to learn more about that, I would recommend looking up S4 objects in R just for the @sign. And that's just going to give you the data frame. Okay, so that's some of the basic tools for importing data into R using the ArcGIS binding package. So I'm going to re-import this data set, but I'm going to just bring in all the fields. So fields equals star and store that as tor crime df. I'll skip through these challenges in the interest of time, and let's go right into, let's perform some analysis, some basic analysis on our ArcGIS data frame. So let's create a few new fields. Let's say Toronto crime df. Let's create a new column called population density and just calculate population over area. Very simple stuff. So we did that. If we want to make sure that that worked, we can use the view function and then go tor_crime df. We'll open up the table, and if we scroll to the end, we can see there's now a population density field or a column in our data set. We can also let's calculate each neighborhood's rate of total major crime incidents per 1,000 inhabitants. So it's just total major crime incidents divided by population times 1,000. And we added another column. Let's say we wanted to add some grouping variables or some grouping columns to our data set. We can use the ntile function or a quantile function from the dplyr package to do so. Let's say we want to calculate quartiles. So the ntile function takes a vector, so the equity score, and then the number of quantiles you want. So we want quartiles, so let's specify 4. And we can create these very quickly. We also did major crime quartiles and equity score quartiles, and we can add these back to our data frame using the $equity rank and $crime rank column names. Okay, so now that we've done that, very simple stuff so far, let's use some of our dplyr knowledge to do some data manipulation and analysis on our ArcGIS data frame. So what I want to do is I want to calculate some basic summary statistics based on major crimes for each crime rank group. So we just defined this crime rank group, and this is just sorting it into 4 different groups that basically ascend in the number of crimes that have been committed per 1,000 inhabitants. So you have 4 groups, each one sort of indicating that more crime has been committed in that group. So what we do is we say, let's create a dummy data frame before we do any of this. and we say summarize df equals, let's take our Tor crime df data frame. Let's group that using the group by function by the crime rank that we just created. So the group by, and now using that grouping, summarize the mean and the sum of all crime incidents in that given grouping. So I'm actually going to comment this out for a second so we can see the result of this. If we go summarize df and we print this out, we can see that we have 4 groups and sort of the mean number of crimes, which ascends by each group, and then the total number of crimes as well. So now let's join this back to our original data frame. What we can do is I'm going to run this all again, and now I'm going to right join back to our Toronto crime df. This is also a function from dplyr, and if you want to learn more about it, use the help file, please. And then we're going to just select these mean and sum columns. So that's all we want. And the right join function is smart enough that it knows to use a common join field. So when I send this through, it will join by the crime rank field. So now that we've created these means, we can add them back to our original data frame. Let's say mean crime grouped equals the summarized df $mean that we just created, and total crime grouped equals summarized df $sum. And if we go view, we can now see that these new columns have been added to our data frame. We've got the mean crime grouped and the total crime grouped that we can sort through. If we want to just ensure that these are actually being grouped, we can sort by the crime rank and see that each one of these, as we change crime groups, we're going to also change the mean crime grouped value. Okay, so that's some simple analysis, and we're not even doing anything spatial right now. Next week's webinar, we will be doing some spatial analysis within R, but I wanted to show you some basic tabular data, sort of data manipulation within R. So now that we've done our sort of analysis, we can output this directly to a geodatabase using the arc.write function. So all we have to do, specify the output location. I'm going to call this the same geodatabase, but I'm going to call the feature class Toronto crime grouped. And then use arc.write, pass in the output location and the data frame you want to write to that location, or the ArcGIS data frame. And there were no errors, so that's always a good sign in R. That means it probably was successful. So let's hop back in ArcGIS Pro and just ensure that everything worked out fine. So if we go to our project pane, we check our databases, and we open the R-ArcGIS data geodatabase, we see we now have a Toronto crime grouped feature class. We can load this into ArcGIS Pro, and of course it picked a great way to symbolize it, so I'm going to change that up. If I click Toronto crime grouped, go to the appearance tab, click symbology, let's change this to graduated colors, and then we'll pick one of these new fields that we created. Let's go with the mean crime grouped. And we can see now we can visualize this and sort of inspect our data set accordingly. So fairly easy stuff, not too complex analysis, but I wanted to demonstrate the workflow, which is more important. You can really do whatever type of analysis, whatever type of data manipulation within R that you wish to do. And next week, we'll be building tools that are going to be doing more complex analyses than what we did in this presentation. So just to finish up what we're working on today. So in closing, one thing I wanted to really mention is that we are very interested in having other members of the R community contribute to the R-ArcGIS bridge. So any of you who are involved in the R community, or anybody really, if you're interested in helping us develop things, we just want to go where the community wants to bring us. So essentially the community should steer the direction of the R-ArcGIS bridge. We have many sample tools available currently on GitHub. There's a link to them right there. And we'll be covering some of these next week during the workshop. If you have any questions, please do contact us. We'll help, and we'll help you write documentation. We'll help you put stuff together. Or if perhaps you are an R package developer yourself, if you want to, we want to enable you to push these packages to as many people as possible, and obviously have full credit for all the work you've done. So if you are a package developer, please contact us, and we'd love to collaborate with you in order to make this a more accessible package. Okay, as far as the resources today, if you want all of the code in the geodatabase, you can use the following link. And this will be, all of this is already available online. So if you want to, I understand we are going relatively quickly through some of this stuff. So if you want to walk through it yourself, feel free to visit that GitHub repo and clone it or download it to your hard drive. So yeah, just a mention of what we'll be covering next week. Very quick review of the ArcGIS binding package. Then we'll go through the basic components of an R-ArcGIS script tool. We'll write a standalone R script that can be attached to an ArcGIS geoprocessing tool. Then we'll construct that tool within ArcGIS Pro and connect that script. And lastly, we will use ArcGIS script tools in a model builder workflow. So you can import these and really develop more complex workflows. I just want to give thanks to the R-ArcGIS Bridge team at Esri US. So this includes Sean, Mark, Steve, Dimitri, and Konstantin. They are the ones who developed this, and it's been incredibly useful to me. Also wanted to thank Hadley Wickham, as we're using many of his packages, and he's really one of the, so many of the packages I use in my day-to-day workflow are developed by Hadley Wickham, as well as RStudio. Lastly, the R Spatial community for all the different methods that we're using, such as SP objects. We want to make sure that we're thanking the people who develop these things first, and we really do appreciate all of these packages that we have access to via R. All right, so just contact information if you wish to contact me. I'm cplouffe@esri.ca, or if you have more direct questions through the R-ArcGIS Bridge team, you can contact r_bridge@esri.com. And please, if there's anything you'd like to see featured in the bridge, say you have an idea and you didn't see it or it isn't currently available, let us know. Because the more demand we know, the more likely we are to implement these things and be able to push them out. So that's really what we're looking for. We want feedback, and we want to collaborate, and we want to work with the community. So that would be very, very beneficial. All right, thank you very much.